So when we're looking at the earliest epoch of the universe, as it is conventionally thought, with the so-called Big Bang, which we describe some of the details of exactly what that event was. Not that was the start of anything, of the start of everything necessarily, but much more part of a cyclical process. But at some of the earliest moments following the Big Bang, here's 10 to the negative 32 seconds going to 1 second, the energy density was at the Planck density, which is the energy density of the vacuum state of space. But that's kind of the implicate order, to follow the terminology of physicist David Bohm. Here it was much more the explicate order that across, wasn't just at the Planck scale that you had these energy densities, because the universe was at the Planck scale. It was at the Planck density. So pressures and densities were so high that space-time itself folded and meshed into a multiply connected space-time geometry of micro wormholes, black hole, white hole systems. This is what we call the space memory network. So in the very first moments of the Big Bang, you had the formation of the space memory network. This is a figure from our paper, The Unified Space Memory Network. And it was formed when these intrinsic black holes, primordial black holes, which follow a wormhole metric, were first initially formed. And so, just a little bit more detail on, when we talk about the Big Bang, we have a model in which that actually initiates as a proton escapes the event horizon of a parallel universe. So we're talking about the multiverse here. And because it's a fractal system, it's kind of like Russian nesting dolls. As that proton escapes, it has the holographic mass equivalent to 10 to the 55 grams, which is the mass of the observable universe. So in this different pressure regime of a larger universe, it rapidly expands. This is called like inflation. But that Planck energy density becomes a multiply connected space-time geometry of micro wormholes. And that is the space memory network. And so this has some relevance to some of our previous unified science reviews, where we were talking about the intrinsic entanglement of space-time arising from micro wormhole connections, a micro wormhole network, and how that was used for quantum energy teleportation, as well as teleporting qubits. But we can see here, just real briefly, the mathematics for this process. Primordial black holes smaller than a solar mass formed in the early universe, where the density is defined by this equation, rho equals 1 over g for any given time squared. This is the gravitational constant. And so we have units of mass, meters, kilograms, seconds. So that will give us a density for any time following the initial Big Bang. So this is the density here two, equation two. This is the density required in a region of space to form an event horizon. So this is like the Schwarzschild condition within Einstein field equations for general relativity. This is the density required for a black hole to form. So we can calculate the mass of a primordial black hole forming at any time following the Big Bang via this density requirement. So at, let's say, a time of the Planck time, 10 to the negative 43 seconds, we can plug that into our equation here for the mass of something satisfying the Schwarzschild condition, a primordial black hole forming at the Planck density. And what we have is at the Planck time, the mass of the black holes forming are of the Planck mass, 10 to the negative 5 grams. So if you're familiar with the holographic solution for quantum gravity, these are the Planck spherical units. They formed at the Planck second, the Planck time following the Big Bang. So they were the first things to form in the early universe. And then as these formed into higher order structures, they formed protons, hadrons, nucleons, the center of the nucleus of atoms. Now, at a time of 1 second, if we plug that into our equation 3 here, primordial black holes would have a mass of 10,000 solar masses, approximately 10 to 38 grams. So the supermassive black holes formed 1 second after the Big Bang, essentially, as primordial black holes. And so that kind of raises the idea that black holes must be everywhere. Now, if you follow our model, where every proton is a black hole, hence every atom is a black hole, this is indeed correct. Black holes are everywhere.